Hi, I'm Bill Snodgrass, and in this episode of The World Around Us, we're doing a virtual lab. We are going to do a types of reaction lab. We're going to do a synthesis reaction, and as we've been doing in our virtual labs, there's going to be multiple sections. First will be setup, procedures, all that stuff. Second, we will conduct the lab, collect the data, and in the last section of the video, we'll discuss, go over the results, and talk about some of the interpretations of that. So let's get some goggles and make something. Synthesis type of reaction. All right, here we are. We're ready to do a synthesis lab. We're going to take some of this and we're going to add some of this, and we're going to get something that is a combination of this and this. What are you talking about? First of all, you should know I found my pen. I've been looking for this for like 2 weeks. I found it. What we have here is steel wool. Steel is iron and other stuff. It is an alloy. Oftentimes it is an alloy of iron and carbon. And then there's other alloys, all kinds of nickel alloys and things like that. I don't exactly know, I just got it. I just got some steel wool, bought some. Didn't actually do chemical decomposition to figure out what it is. So it's steel wool. We're going to call it steel wool. What we're going to do is we're going to react the iron in the steel wool with the air in the atmosphere. An alloy is a mixture. Air is a mixture. And so we're going to take parts of the two mixtures and we're going to create something in here. We need something to burn this in, and we need so we need to find the masses, starting with the evaporating dish. Mass is 51.33. If you're doing this in class, you're going to have to find an evaporating dish, a clean evaporating dish, and find the mass of it. Write that down. Then we're going to get a sample of the steel wool. Acquire that from whoever is facilitating your lab, and you're going to put that on the scale, trying to get all of it on the scale so it's not like supporting itself partially. And I am coming up with 3.42 in this setup. Now here's the hard part of this. We need this to be fluffy so that there's a lot of room between the strands of steel wool, but we also need it to fit inside the evaporating dish. There's going to be several errors in this version of the lab. One is we don't actually know the composition of this. So there's going to be some of that 3.42 grams is not steel wool. I've already lost some of my sample onto the surface around it. A small amount of the steel wool fibers has come off. So there's another error. When I set this on fire, it's going to begin to spark, hence the goggles and the fire-safe surface. It's going to spark a little bit, and so we're going to lose a little bit more at the end. What we're going to ultimately do is reduce this down. We have the mass of the evaporating dish and the mass of the steel wool. We're going to take the mass when it's over with, and if this works as it did in practices, the air molecules will have been reacted with the iron molecules such that the final mass is greater than the sum of these two parts. So we're going to end up with more than 54.75 grams if everything works. So that is the setup. Procedure-wise, we're going to light the Bunsen burner using one of these things that you can buy at a hardware store or on Amazon. They're basically welding lighters. The kids in my class love to play with these things and want to know where can you get them. I'm going to light the Bunsen burner, which we're going to use simply to ignite the steel wool. And it's just going to basically stick it in there, and it's going to ignite the steel wool. The steel wool is going to burn down. All right? So I'm going to conduct that, and then we'll collect the results afterwards. So here we go. We're going to, procedure-wise, hold it by the bottom, hold it by the rubber. Don't hold it by the brass thing. That would be very, very, very bad. And we're just going to ignite the steel wool, which we have made fluffy. We're going to let that burn. Pieces of it are falling all over the place. I'm going to try to guide it back into the evaporating dish and just let that burn. Turn the Bunsen burner off. Being careful not to reach across it with my hand and set myself on fire. Because I fluffed it out, there's enough air to get in, and we have the burning of the steel wool. The first thing we're going to notice is that it's changing color. We'll talk about that a little bit in the results section, more in the discussion section. So there you have steel wool burning. You can also ignite it with a 9-volt battery that's sometimes very dramatic. And there you have your procedures. So we're going to fluff out the steel wool. We find the mass of the steel wool. We find the mass of the evaporating dish. Now we're going to weigh them together and find what the new mass is. That'll be in the results section, and then we're going to discuss it. Now the evaporating dish is a little bit hot because it's had a fire in it. So be very careful. Make sure that it's something that you can manipulate without harming yourself. All right, if you're still watching the video, you are here for the results. We're going to find out what happened here. We're going to find out what happened. First of all, we have to know what the mass of the sample and the evaporating dish was to start with. In this case, it is 54.75. That was the original mass of so originally we had 51.33 for the evaporating dish and 3.42 for the steel wool. It is very touchable. I'm going to put it on here, trying to get everything and keep it all in there. Keeping it all in. I have a final mass of, so the mass of the product and the evaporating dish equals 55.22. Subtracting off the mass of the original parts, which is 54.75, that will give me the mass that was added to by grabbing air molecules from outside in the atmosphere. And so, calculating 55.22 minus 54.75 results in a mass gain of 0.47 grams. So the 0.47 grams had to come from somewhere. That's the point of this reaction. All right, so if you're doing this as a virtual lab, you now have all of the information that you need. We've collected the data, and you're ready to go write up your results and write your conclusion in the worksheet, which is attached to this video down in the description section. All right, let's talk a little bit about what happened here. All right, so we have our balanced chemical reaction. We have the oxygen, we have the iron, they combined. There's a lot of errors in this that's going to prevent us from doing a whole lot more than just observe that mass was increased. We lost a lot of the reaction. There's pieces of the original 3.42 grams that came off as I was trying to get it fluffed out, so that was partially lost. Also, we don't really know what we started with. We have steel wool, which is some combination of iron and other things, probably carbon in this case, but we don't know what the composition was. We don't know what that was. Also, we don't know we didn't even begin to talk about possible secondary reactions, possible reactions of other gases in the atmosphere with the reactant. It could have, not likely, but it could have been that something else reacted. So there's a lot of pieces that are not accounted for. In order to do any kind of like stoichiometry, so if we were to say that we had 0.47 grams of oxygen, that's a pretty safe bet. We can go back to how many grams, stoichiometrically, go back to how many grams of iron we should have had to start with. And we could do that math, but we're starting with so many pieces missing, like this little pile of stuff that's, you know, on the desk, that to do that and to claim any sort of accuracy is kind of like overstating what the science. But as an exercise, we could take this 0.47, calculate it backwards into how many grams of, or how many grams of iron were actually consumed up in this process. If you wanted to do this in a more sophisticated way, you could probably find a way of containing your steel wool better so that you don't lose parts of it off on the table. You could probably find from there a very more accurate results and do more of the stoichiometry. So the discussion could include all of the sources of error. We're also dealing with you know, a class laboratory scale, also a limitation to it, and those are just some of the errors that are present. So if you are looking for lots of ways of discussing error, we don't actually know that we actually, in fact, you can see that some of the iron did not even react. So there's yet another source of error. But this does bring in an interesting thing. One of the evidences of a chemical change is a color change. And we can see that the color of the iron, the color of the steel wool obviously changed from that silver gray to that bluish gray. So we do have another thing we could discuss is evidence of a chemical reaction is color change. All right, so there's your discussion section. Nothing profound here. I'm not going to do the stoichiometry because there's so many pieces of it that were inaccurate. What we can say from this is that the mass gain clearly came from somewhere. The only way to explain that mass gain is in the chemical reaction, a new substance was formed, and that was formed from the iron and the oxygen in the atmosphere. Thank you for watching. Please click the like button, subscribe to the channel, sign up for notifications, leave me a comment, question, or suggestion. That is all for this episode. Oh, didn't catch it. See you in the next one.